Okay, I think we are good to start. So we have nearly 50 people on the bridge. So thanks a lot for everybody to make yourselves available to join this webinar. This webinar is on AI/ML on AWS. It was set up with the JRC, but people from other EU institutions and agencies are welcome to join as well. So feel welcome if you are from another EU body to stay with us. So I hope you can all see my screen. So some practical info before we dive into the presentations. So you should be able to log your questions in the chat. There will be also some a short Q&A at the end of each session. So to handle a few questions at that time, we will also have a larger Q&A at 5 o'clock or a little bit after 5 o'clock. To address as many questions as possible. Probably we will not be able to address all the questions, of course, but we are logging all the questions that you are submitting, and we will answer them later on as well through a document. The slides and this session will be shared afterwards on a link that will be shared with you. And last but not least, we will also share a survey. We very much appreciate your feedback. This is what makes us improve. So please spend some time on the survey if possible so that we can further improve these experiences. So let me then go through the agenda. So to start, I will give a short introduction on the EC's cloud journey. For some people, maybe they already know it, but about a month ago, we already did a Cloud 2 webinar that is available to you, the recording as well. So you can also go there if you want more extensive information on the EC's cloud journey, but here I will just touch a few points, and especially how to start with AWS as an EU body. After that, Neil, our Senior Business Development Manager for AI/ML in EMEA, will provide an overview of the AI/ML stack at AWS, present some use cases, and also go over the foundations that go with the AI/ML stack. Before the break, we also have Vincent, a solution architect on the team for the EU institutions, and he will guide you through a step-by-step process in Amazon SageMaker Studio to build, train, and deploy machine learning models. Following that, we will have a short break. And after that break, Jet will introduce the Open Data Program at AWS. So that program is actually about hosting public data sets, making data sets available. Why are organizations doing that? And how are organizations using those data sets? Some are very large, and still they can use these data sets in a very cost-efficient way to build applications and tools on that. And finally, Delger, a data scientist in AWS, she will introduce you the ML Solutions Lab program. So this is a program where we nominate use cases to build an MVP, so a minimum viable product review in 8 to 12 weeks to show how machine learning models can be deployed on AWS. And at 5:10, we will have 20 minutes to go further on the questions that have been logged. So I will start with a journey. So I will go quickly through this. As I said, there's another webinar that was spending a lot of time on that. So the EU Commission's cloud journey actually effectively started in 2014, we can say, with Cloud One. There were no cloud service providers directly present on Cloud One. It was more in an indirect presence. It was a prototype framework, we can say, to test out cloud usage, to identify the benefits of the cloud amongst the EU institutions. And that was kicked off in 2014, 2015. Then we saw the first cloud use cases in 16, mainly lift and shift use cases, basic compute services were used. And it's as from 2018 and especially last year that we see a large uptake of AWS services amongst the EU bodies. Especially also we see now more and more cloud native services usage, so serverless usage and cloud native database services. Also cloud native architecture, so more loosely coupled architectures and using microservices. All this was actually the ramp up towards the interinstitutional Cloud 2 framework. So, and this framework process was started at the end of 2018, was built up in 2019, and finally, was established in 2020. So there are several different objectives in this Cloud 2 framework, and it depends on, and these objectives are actually split in different DPSs or different lots. So if we look at the Cloud 2 framework, actually there are 4 lots or DPSs, dynamic purchasing systems. The first one is for the cloud service providers themselves. The Commission and the EU institutions want to have a direct presence from the cloud service providers on the framework, to have this direct relationship for, of course, contractual reasons, but also commercial reasons. So this was the first objective. Then a second lot will open in 2 weeks, which is DPS 2. And there it mainly targets our partners. We will provide professional services that go along with cloud platforms. The cloud service providers will also be present there, but most of the cloud professional services are actually delivered by our partners. There's also a lot for private cloud and also for SaaS, but these 2 lots are actually more are planned for end of this year or most likely for 2021. On Cloud 2, we have 65 different institutions and agencies. So I think all the people present here, I checked quickly, are across the EU bodies that are present here on this call. All of them are actually on Cloud 2. So as I said, and I want to make this clear, but because we got some questions after the previous webinar on that. So the first Cloud 2 contract was awarded to AWS in January and was signed, is already signed. And so that means that actually since January, you can, as an EU institution or agency, actually procure AWS services. So I will explain later on how to do that. Yeah, some very practical advice on how to get started. Actually, the main message on this slide is very clear. There are 2 email addresses to remember, and that is the one from the cloud broker team at the Commission, and the one lower on this slide, which is the one from the AWS team that is supporting Cloud 2, and that you can see here as well. So if you have any question on how to get started, well, send your request to one of these email addresses and we will guide you through the process. The cloud broker team at the Commission is there to assist you with estimates, with business case estimates, and to advise you on the different services and cloud services that are offered in Cloud 2. And they can also provide you an AWS account. So that's actually more from an administrative point of view. So, but it's very good because it removed already a lot of hurdles that were existing today. So it's very easy to start now with a sandbox account, to start playing and to start building a pilot on AWS. You just need to contact the cloud broker team and they can provide you an account after a few due diligence questions, let's say. There's also a wiki page that has been made by the cloud broker team. You can access it with an EU login credential, and there the most common questions are addressed. This wiki page has to be updated just for your information. So in the coming months, it will be further updated so that it will be completely in line with the very latest information of Cloud 2. There's also an AWS FAQ on that same wiki page, and there you can find a lot of questions on who are your point of contacts within the AWS team, some basic fundamental questions and answers on security and compliance, and some
I think we have some technical glitch, and Anthony will be back on the presentation in a few minutes, please. Apologies for the inconvenience. Please bear with us. Okay, while Anthony gets his technical glitch in internet sorted, we will move on to the next session. May I please request and welcome Neil Mecken, who is going to give us an overview on AWS AI and MLSAC, and he's going to share some use cases with us. Over to you, Neil.
Thank you very much. Could you just guide me through taking over the screen share, please?
Yes.
What do I do to take the screen over?
You are the presenter now, and through the sharing tab, you should be able to share your screen.
Okay, I think I may be doing that.
Yes.
I fear I may be showing the wrong screen. Does that look like my title slide, everyone? So it'd be great to get a little bit of feedback to check I'm sharing the title slide better data decisions.
Yes.
Which, yes, fantastic. Thank you. Thank you. So my name's Neil Mackin. I lead our small team focused on helping public sector organizations exploit artificial intelligence and machine learning. And I wanted to share with you all some thoughts around this area to overview why it's actually incredibly effective to use our platforms for AWS platforms for artificial intelligence machine learning. And I wanted to overview the stack of functionality that we have, the capabilities, the services, the tools. And then I was going to hand on to Vincent to do a deeper dive and a demonstration of some of the things which I'm going to talk around. But by way of a starting point, it's perhaps worth reflecting on the long heritage actually that Amazon has got in this space. I've had the privilege of talking around machine learning and data mining and predictive analytics for many decades now. And actually for a lot of that time, I've often used Amazon as one of the exemplars around next best action recommendations, that personalization on the Amazon retail site that says that people who are interested in these products might be interested in others. Similarly, not only have we invested heavily in that space, we've invested very heavily through the retail operation of Amazon in areas around prediction and forecasting, trying to understand what products will sell, how quickly to buy, how quickly to stock, and in order to try to fulfill everything that people want to buy, how do we actually manage our infrastructure and manage our supply chains? bringing that into machine learning, it means that we have invested incredibly heavily for decades in predictive capabilities and forecasting capabilities. We're also researching and rolling out new capabilities, for example, around drones, around voice interactions with Alexa, and moving Alexa into a number of different contexts, perhaps Alexa in the car, to have voice interactions in the car. Entirely new shopping experiences like Amazon Go, which are retail stores, supermarkets that we've opened up that allow people to check in as they walk in with an Amazon account. We use it on an app on their phone, and then go and pick things off the shelves that they want, put them in the bags or in the pockets, and then walk out of the store with no checkout whatsoever, because we're using AI and machine learning extensively to actually track what everybody's taking off the shelves and what everybody's putting back on the shelves. A phenomenal piece of machine learning capability, which has been brought into production so that it actually transforms the way people are living. Similarly with drones, we're currently on the edge of moving into using drones routinely, and some of the interesting challenges there. I mean, if you're wanting to land a drone to deliver a parcel, we're looking from cameras looking downwards to actually track, is this a safe place to land? Is it large enough? Is it flat enough? Is it safe? But also just looking down thinking, well, is there anything like a washing line that's going to be in the way? And detecting that from the images. So doing really intense image processing and analysis in real time as the drone is hovering down. So that sets a little bit of the backdrop, the history, the heritage, if you will. But AI and machine learning is only one piece. It's only the predictive capability, and it's worth taking a broader view and thinking about the data management requirement for this. Over on the left-hand side, the ability to pull in data from multiple different sources, be that unstructured data, be that images from satellites, be that sound, be that videos, be that emails or documents that people have submitted. The ability to pull in semi-structured data, maybe coming off sensors or mobile, maybe point of sale terminals, data that is sort of structured, conforms to some sort of predefined schema, but isn't necessarily sort of tabular. And then up at the top left, the structured data that we can easily pull from many different systems which have been designed around processing tabular data. So CRM systems or ERP systems, many line of business systems. And all this data flows really in two different modes, either batch loads or streaming modes, where you flow the data in real time or when you take it in large chunks. And we have, in essence, services to support all these different modes of interaction, all these different models of working. At the heart of a lot of what we do is actually what we call S3, which is our object store, the ability to persist things in buckets, as we call them, and to persist them incredibly securely and stably. And we can build very flexible data lakes of ingesting volumes of data and managing it. And from there, that gives us the ability to move off into the two broad areas of analytics, taking the ability to bring sort of data warehouse type capabilities from Amazon Redshift, or in fact any of the, I think, 8 or 9 other purpose-built database services that we now have. So if you had time series data, we have a time series specific database server now. So we have a number of purpose-built database servers for different kinds of data applications. Really down to the bottom right with machine learning and the capabilities we have there, which I was going to talk to in more as we go on. But I wanted first just to kind of ask the question, why? Why do we think you might want to use AWS for analytics and machine learning? And there's really 4 broad themes here that's worth unpacking. One is the speed, the ease, the capabilities of getting data lakes built really quickly and really easily, the ability to ingest data, the ability to create serverless data lakes, if you will, the ability to use pre-built services like data lake formation, which lets you ingest the data, discover the structure of the data, create views that users can access and use, to manage the access to that data and security, and to manage those resources in an on-demand kind of way, really quickly and really simply. We have invested enormously in security and managing the security of data for people. And we have focused very much on making services open, ability to use open things, the ability to scale. So at the heart is the single storage layer or simple storage layer, or S3, which enables all the data to be held and managed and put forward. And you can build a secure data lake in just days. Really, it's very quick, very fast to use S3 as the basis for your analytics. We've also integrated all of our other services really deeply and really tightly into S3. Stepping on top of that, we have invested really heavily in terms of security. So tracking who is accessing the data and a number of services on the left-hand side around security to give assurance that nobody can access the data who shouldn't be able to, and to track exactly what the data is and to give the controls. We have a number of services around identity management and extensive capabilities around encryption. So you can encrypt the data at rest or in transit. You can encrypt the data as it moves in and out of a number of services. You can manage it with our key management service, or you can manage it with your own services, and tracking on the compliance side. It's worth saying that we will, I think, be having in a few weeks' time another seminar around security. So if you want to dive deeper into these areas, we could happily share with you at great length. We have extensive certifications in terms of our capabilities around security that many other organizations rely upon. And I understand that we meet all of the Cloud 2 directives that you need to work to in terms of security, and we'll be happy to unpack the ways in which we do that in that seminar, or reach out and ask what it is you need to explore there. In terms of comprehensive and open, we have arranged the capabilities around the batch movement, the migration and the streaming of data at the bottom of this, the data lake infrastructure, and the moving up into the analytics in a number of different ways. And then right on top, the ability to move into predictive analytics and machine learning through to visualization and dashboarding. It's a very flexible capability that you can draw together in different ways. And we have a large number of services in different areas here. So at the bottom, a number of different ways of moving data around, managing bulk extracts or real-time streams. We have the capabilities around the data lake infrastructure itself, storing data, analyzing the data, building new data lakes. Several different flavors of ways of doing the analytics, from tools like Spark and Python, or Spark and Hadoop, through to Redshift, data warehouse, and in-memory processing, and moving over to kind of analysis of data as it flies through. And then really at the top, a number of services I'm going to dive deeper into as we go. What is worth mentioning, though, is our commitment to open standards, open formats. And here is a screen full of the different open source standards which we support and will allow you to use in your analytics and machine learning as you wish to. So drawing this together, it's an incredibly scalable infrastructure. It allows you to use servers, compute instances, which are the right size for the job that you've got. You can choose between many different flavors, from the most powerful GPU instances, P3DNs, right down to the most cost-efficient and low cost to run inference engines like Inferentia and the chips that we're developing there. You can scale these, but you can also use things like spot instances, which is, in essence, we allow people to use our compute instances in an on-demand way. So if you've got a particular load and you want to operate it now, you can just request and do that. But if you're prepared to say, well, it's okay if I got interrupted. It's okay if maybe somebody else wanted to use that compute resource. Then we also have a spot instance capability, which in essence is us looking right across our huge fleet of compute resource and identifying the ones which are presently not being used for on demand and making them available at a massive discount, sometimes sort of 70–80% discounting on the cost of running them. For certain jobs, perhaps long-running machine learning challenges, long-running training jobs, it would be ideal to train them on the spot instance instead and massively reduce the cost. Thinking through the other aspects of this, we've got a huge bandwidth in network interfaces. So if you've got high volumes of data which need to flow through, we've got capabilities of managing bandwidth constrained things, memory constrained things, data constrained things, all the different kind of constraints we could manage to. And on the data storage, we can help support storing the data in an intelligent, cost-effective way. So some data you need to have ready access to, and we would enable that. Some data you may only need to pull back from archive and wish to be prepared to go, if you could store it at a much, much lower price, but when I pull it back, I'll pay you each time I do so. We've got mechanisms for doing that. So there's a huge range of data management and data storage capabilities. Examples of the way people build analytical platforms, EMR, Redshift, Athena and QuickSight, really fast analytical capabilities built on top of this infrastructure, all of which builds towards a capability of addressing the problems that you've got in a fast and effective way. And maybe that's kind of an interesting point, because this slide fundamentally talks about what we often talk to as the benefits of using cloud. The benefits are, you don't necessarily need to work out how big the compute infrastructure needs to be before you begin and build that with an upfront expense. You can leverage the massive economies of scale as the global investment and research is taking effect in our services. You can realize the benefits of that. You can avoid having to guess up front how much capacity you're going to need and actually allow the work you're doing on the problem to help you work that out as you go. So stop guessing capacity. The ability to test out different techniques, to try out different approaches, to throw compute infrastructure together in a way that lets you tackle a problem in a really agile and fast way, and learn if it doesn't work, you could tear it down again, and you've spent, well, a few cents, a few euros just trying things out. Focusing very much on the real work that you're trying to do instead of the real work of managing data centers. What is interesting to me, though, is each of these areas are the arguments that we often have with people to help them realize the benefits of cloud computing as a whole. But to me, they fit incredibly well for machine learning and AI, in that most machine learning problems, it's really hard to predict what kind of computational workload you're going to get before you've got into choosing the algorithm and choosing the data and looking at the data. It's often quite hard to predict how big a data set you're going to need in order to actually solve the problem at an acceptable level of accuracy. It's ideal to have the ability to swap in different algorithms, to try things out, to experiment, and very much to be stepping away from having to guess the capacity you need, be that the capacity for computational crunching, or the capacity for data, or the capacity for data flows and data bandwidth requirements. The ability to test and learn, to genuinely iterate and genuinely test things out in an agile way is phenomenally helpful in machine learning and AI, which is intrinsically a very iterative, very experimental thing. So we have been focusing on helping make AI and machine learning easier. And there's three kind of areas that we've been really focused on thinking about in this space. One is that data scientists spend most of their time not doing what is fundamentally data science, but it's often, the surveys often show they spend about 20% of their time actually doing the data science piece, and the rest of their time doing things like managing compute infrastructure, or managing data, or managing the data prep, or managing the pipelines. We need to make that quicker and easier and more effective for them, and we focus very much on that. We've also identified that an awful lot of companies, organizations, recognize the value that big data will bring, but very few of them are actually generating strategic insight from it. So how can we make it more effective and quicker and easier for people to use these techniques? We've looked very much at that. And then finally, the fascinating statistic that of all of the predictive models that get built, only half of them ever actually make it into a production, make it into being operationalized or get implemented in some way that drives value. And if you don't use the predictive model, you will get no value from it at all. So these are the kind of three broad things we've spent a lot of our research time focused on trying to address. And we've distilled our mission, as it were, is to put machine learning into the hands of every developer, to make it easier for developers to access machine learning and AI services, and to make it easier for data scientists to be effective and to be productive doing the data science bit, not the rest of that work. So with that as our mission, we have broken out our capabilities into 3 layers. And this is the machine learning stack at the moment. It keeps growing each year. There's probably going to come a day when we need to have multiple slides to present our single stack, but this is our stack at the moment. And the 3 layers here. So at the bottom, we've got the frameworks and the infrastructure, the fundamental foundational layer. The next layer, we've got SageMaker, a machine learning productivity platform to build machine learning models quicker and easier. And at the top, we've got pre-built AI services, where we, AWS, have already put the energy into training them, energy into making a service that you can quickly use. So for example, if you wanted to take an audio stream, to transcribe it into the written words, we've built models to do that in our Amazon Transcribe service already. So I'm going to step through these in turn, and we're going to do a demonstration of the SageMaker layer in the next session after this. So thinking about this bottom layer, we've focused very hard on making the compute instances we've got quicker and easier to use with machine learning frameworks. So all the different machine learning frameworks that are available today, like TensorFlow or PyTorch or LXNet, we've found ways of making them work incredibly well on our compute instances. As a testament to that, it's interesting just to think about TensorFlow. Although it's sort of controlled by Google and released, if you actually do the analysis of TensorFlow implementations in the cloud, over 85% of them are actually running in AWS. And part of that is the way that we've implemented it, that it runs better on the AWS infrastructure. It's a very fast and effective way of working. We've made it possible for people to open up a compute instance with all of these libraries pre-installed. So the deep learning containers or the deep learning Amazon machine images, the DL-AMIs, these have all of these libraries pre-installed. So it's not a case that you would access the compute infrastructure and then start loading all the libraries and getting them all the versions of things to talk to each other. We've taken that pain away, simplified it, made it quicker and easier to get started. We've got a wide range of different compute instance types, some of which, as I suggested earlier, are incredibly powerful from a computational point of view, most powerful GPU processors. Some of them are most incredibly effective in terms of the amount of memory that they can hold at once. Some of them in terms of the bandwidth and the interconnects between others. So regardless of the shape of the problem, we could configure the right mix of CP compute instance for you to use. Getting ahead of myself, but elastic inference, we've put a lot of time and energy in terms of thinking, how could we actually make the cost of running inference lower for people. And if you think fundamentally, having built a machine learning model, it often requires a mix between CPU processing and GPU processing. You know, the array processing in GPUs is fantastic, but it doesn't solve everything. And if you then run it on a single instance that's either a CPU processor or a GPU processor, you have to make a compromise, and it's usually quite an expensive one. We've created the elastic inference capability that lets you put variable amounts of GPU processor alongside a CPU processor. So you can mix and match and meld these together to get a more effective combination. We are seeing people save significant amounts by that approach. And we've also got research into chip designs, like Inferentia is a chip that we're designing and releasing. We've got our new Inferentia-based instances now, which have been absolutely focused on lowering the cost of running inference in the server themselves. So it can be the most effective way of doing it. We've also released, interesting, it's worth mentioning at this level, a service called Neo, which is a compiler for machine learning models. So having built a model, if you want to run it, like just as in the old days when you writing software, when you compile the software, if you do it to a very specific target chipset, you could actually run it more efficiently, run it faster, run it in less memory, less energy, less computational cycles. The same is true for machine learning models. So we've open sourced a project called Neo, which allows you to compile models you built in machine learning to specific chipsets, which can be, well, it could be a chipset anywhere. It could be a chipset in our cloud, or perhaps in somebody else's, or at the edge if you want to download things to the edge and run them there. This lowest level, though, the frameworks and infrastructure level, is a level where we see a lot of research scientists using it, but very much crafting their models by hand, which is really quite hard and is not typically very productive. It is the lowest level out of which we build all the others, but it's interesting to see over time some of the research science communities are actually moving up and starting to exploit the SageMaker level instead, because it's quicker and more productive to do so. That said, everything that you can do in the lowest level, you could move up and actually access it through SageMaker instead. So with that said, let me step up into the middle layer. I've described that it's incredibly difficult to gain the skills necessary to be effective at producing machine learning at that lowest level. And that's really why we've focused on creating SageMaker, to make it easier. Oftentimes people won't have enough machine learning practitioners. Wouldn't it be better if we had the capability to give people an environment that's quicker and more effective and easier for them to use, that actually manages a lot of the work for them? And that's precisely SageMaker. So within SageMaker, there's capabilities around preparation and collection and labeling of data, of building to identify the particular machine learning models algorithms you want to use, then the training and tuning stage to actually set up the environments to train, debug, and tune the models, right through to deployment. It's probably worth trying to call out that machine learning in SageMaker takes away the management of the computational infrastructure, and it does it for you. So at the very essence, the ability to set up and manage environments for training means that as a data scientist, I could focus on writing, in an environment I like, perhaps a Jupyter notebook, writing in Python, getting to the point where I've prepared my data and said, well, this training set with these parameters, I want to run it into this algorithm to build a model. And then instead of all the work of actually setting up the compute infrastructure, I could just run one line of code in SageMaker and it will manage the compute infrastructure in the background for me. It will build up that new computational instance that I've specified. It will flow the data in, it will flow what it needs to run the algorithms to do the training, and it will save the resultant model and persist it and back. And all I'm doing is focusing on the actual data science challenge instead of thinking about how do I run a cluster of these compute instances, how do I manage my data in and out, how do I do all that? Over on the right-hand side of this diagram, the deploy and manage. We've recognized there's a real challenge that an awful lot of machine learning is intrinsically experimental, and it's often done in a way that's quite different from traditional production IT worlds. So one is kind of, let's explore and innovate and using modern languages, using new techniques, and the other is more sort of ITIL controlled and managed. The two are quite different from one another, and we've made it easier to deploy models into production, to wrap them up perhaps in a container with a web service interface that lets you flow data in, do the inference, and then flow to get the results back. We've created capabilities to monitor those models over time, to validate how they're running, and the ability to scale things. And that scaling is in all directions. Interestingly, it's scaling from a case of how do I actually scale up to a burst capability to manage huge numbers of inferences, but also scale down. I mean, maybe the workload that you've got is something that doesn't need any inference to run at night or at the weekend, in which case it could scale right down to cost very, very little indeed. So let's just unpack some of these. As I said earlier, Vincent is going to demonstrate these, but over on the left-hand side, we've got a service called Ground Truth that allows you to do labeling of data, and it actually builds a model as it's going, as you're labeling the data, to do auto labeling for you. And we're seeing huge reductions in effort required because it learns as it goes, then uses a human pool of human resource to do the labeling, some of which it can actually automatically infill for you. So we're seeing something like 70% reductions in effort for people doing labeling jobs, really focusing on human labor on the right parts of that problem. We've got an interface with notebooks in a capability that's easy to share and collaborate. We've got the ability to do debugging and optimization, to track experiments over time, right through the deployment side. I mean, it's probably worth stepping up, thinking what we're doing here is creating an integrated development environment for machine learning, a little bit like people have done in the past around software engineering. But everything you need, from version control, from persistence, from tracking, from experiment monitoring, from debugging, through monitoring how things are running, all that capability we're wrapping into one environment in Amazon SageMaker. So let me step through a few of the aspects of this. We've got the studio environment as a fully integrated development environment for it, capturing each of these different areas. So the ability to collaborate, share notebooks with one another, the ability to manage experiments and to share and track thousands of things going on at once. We've got an auto ML capability written into this as well. You can produce better quality machine learning models, but most of all, you can do it with much, much greater productivity. So we're going to have a look at it later, but here's a quick preview. You can use it using the Jupyter Labs environment with Python or R code. You can then track and use the visualizations to track it. It's maybe worth mentioning, though, that if you focus solely on SageMaker as being the console application or the studio application, it is all of that, but it's more. It's also the fundamental underpinnings for the managed environment, which actually means you could, and we have a number of customers who do, having developed models in this easy to use integrated environment, step back and actually implement them in a kind of ML ops, lights out, driving it through command line and driving it through scripts. And that's totally okay. So you could have data landing in an S3 bucket, which is picked up, retrain models, test the retrained models against reference to that, decide if they're better than the production ones, then perhaps promote them into production or not. It's entirely possible. So stepping through, you've got these notebooks which allow you to collaborate, to share. We've also tackled the problem that the environments which sort of solution architects using cloud typically uses to log into our console, to look at things in that way and to build things out. But it's much easier to actually have a single sign-on that accesses straight into the environment for you. So you can fire straight into your notebook. And we find that data scientists and machine learning practitioners prefer that approach. So we've made that possible. It's easy then to share the notebooks with one another, and all the background infrastructure is shared for other people to use. We baked into SageMaker a wide range of algorithms that tackle most of the common data science machine learning challenges. It's entirely possible to create your own algorithms though, or to code at the lower levels of like TensorFlow and MXNet and bring that up in a script mode into SageMaker as well. So it's open to more, but these are already baked in. So in terms of the training, I've talked about the ability to do this. It's probably going to be easiest to let Vincent show this for you. So let me skip on and say we've created a debugger within the building of deep learning models. So if you're actually busy training an algorithm, wondering why is it not training, why is it not converging, we've got the capability to analyze the tensors as it goes, create rules to flag up what's going wrong, to massively improve the speed with which you can develop. And we can deploy, and the deployment can be wherever. So I've actually got some customers who manage their own deployment environment, take the models they bake out of SageMaker, put them into their world, and others who flick it around and do it the other way. So it's entirely open. Monitoring over time. If you create a model based on one set of data, it's incredibly important to reflect on, has the data changed or not as it's in production? So with Model Monitor, with the capability to analyze the characteristics of the data that were used for training, and then analyze as you're running it in production to see if there's any variation, if there's any concept drift, to flag that up and to alert, to enable you to have the moment to rebuild if you need to. An autopilot is a capability to build machine learning models from scratch. So you just tell it, this is the data set, this is what I want you to go and predict or classify, and it will identify the algorithms, it will create additional features, it will build it for you, run many, many runs. But what is fascinating is it's completely open. It gives you the results. It's not like a black box, but it actually shows you all the code it's worked. So I often challenge people who run data science teams to have, whenever they start a new project, to have the first day, just run autopilot, get a baseline, then spend the rest of your time trying to improve what you've already got if you can. I wanted to step back and show some of the ways this is used and to give a few examples. So augmented AI is a capability we've created because for some situations, you need to recognize that AI will not be perfect. It won't get everything correct all the time. And you need to blend together human experts to review the things the machine learning model hasn't got right, to correct them. And that's what we've created with a service called Augmented AI, or A2I. And in doing this, we've worked with other people. For example, in the UK, the health service actually analysed all the prescriptions to understand what was written by all the doctors on paper. And that's kind of quite a capability to actually ingest from, for example, on the left-hand side, these prescriptions and read off all the different things which have been written on them, which is great if you're using AI to do that. But when you're presented with prescriptions which have been written perhaps like this one, it's really hard to believe that a machine learning model will be 100% accurate on something which I'm not sure humans would necessarily agree on. So we've created this capability to flow low confidence prescriptions to a human reviewer, and this is actually the interface that they would get, and allow them to correct or augment what's already been done by the AI. The health service have actually seen this and recognized it's a bit of a game changer. But what is interesting is it makes it quicker and easier to put things into production, quicker and easier for people to trust to put machine learning models into production because they've got a human safety net underneath. I wanted to share a few customer stories as well at this point. So GE Healthcare make those big machines that take images in hospitals. So MRI scans or X-rays or radiographs, lots of different kind of analyses with different technologies that basically take images. They focused in a very, very big way at thinking, how can we bring the expertise of the radiographer to bear within the device? And they're thinking at a global level, we will never have enough skill. We'll never have enough skilled radiographers to actually look at every radiograph for everybody. How could we bring to bear expertise that they would have and analyze them, which is, in countries perhaps where most of us are from, it may be quite easy to get access to that kind of level skill. If you are in a big city and you need it perhaps during the weekday, during the working hours, but maybe outside of those, or outside of the cities, or in the rural areas, or in the less, in the more deprived countries around the world, radiologists are incredibly sparse. So can we take the expertise of what they're looking at in those scans and flag up the conditions? And that's exactly what they're doing across a number of different capabilities, from analysis of lungs, lung x-rays, through to analysis of the images that you take of babies in the womb to track the key criteria and measurements that you do through pregnancy. In a completely different way, College Board is an educational provider, and they standardized, they set and manage assessment tests for all their students, and they do that through the year. And they'd always traditionally had certain slots where they were allowed to do tests. They used a machine learning model to actually analyze when would the best times be to do these tests, and came up with a very innovative answer. Well, why not use August, which they'd never really thought about before, but actually it was remarkably effective and proved incredibly popular. Another example, in the country where I am, all the cars and lorries in this country need to be tested for the roadworthiness by inspectors, and all those inspectors are then checked by an overseeing regulatory body to actually track that they're doing it right and they're not being fraudulent. So there's 66,000 testers across 24,000 garages, and they used a partner used SageMaker to analyze and triage where would you send your inspectors to try to identify fraud, and they found an incredible boost to the performance by doing this. It's also interesting in different areas, like in terms of usage of certain critical resource. So the Beth Israel Deaconess Medical Center had a surgery rate improvement. The utilization of their most critical infrastructure, the actual operating theatres, they boosted that by using analysis in SageMaker to identify whether or not patients had consented in all the previous paperwork and forms. So it's interesting how one thing can flow to another. And also the Hydrographic Office in the UK had used deep learning on Sentinel-2 imagery to try to identify and locate mangroves, mangrove swamps, and the extent of the mangrove growth, which actually is a key indicator of sea level changes due to global warming. So I wanted to step up to the top of the stack and highlight that there is a wide range of AI services which we've already baked in solutions which are pre-built and easy to use. For example, the image recognition, we've got a service called Recognition that will do facial recognition or object detection within images or videos and track movement within them. We've got capabilities around speech. I think I mentioned earlier Transcribe, that will take an audio feed and create the written record of what's been said, or Polly, that kind of does the opposite and will create incredibly lifelike speech from the written word. An example there is there's an environmental agency giving out flood warnings, which uses Polly to create hyper-localized flood warnings in a very realistic voice. So it would describe in very local detail how a river may flood in a local area and warn people in that area. Comprehend implements a natural language processing capability to identify the entities and the topics within written text, to actually identify what is this text about, what are the people it's being talked about, the locations, the dates, the entities, the sentiment within the text. Translates between languages to extract as a service, and I think the example I gave earlier of the health service with the prescriptions, it's a document understanding service. So it can ingest documents and in a machine readable way identify all the elements within the document to actually pull back what fields there are and turn that into a machine readable XML or JSON file. We've got Kendra as a enterprise search capability with natural language understanding. So if you have a corpus of documents, perhaps a load of legal contracts, perhaps a load of policy guides, perhaps a load of research information, and you wanted to be able to ask a natural language question and be prompted back with what the right answers might be, Kendra is a way of ingesting all that and creating that capability. Lex has the ability to create chatbots to actually give automated interactions, often put together with services like Translate to allow questions to be automatically answered from multiple different languages by translating for Lex to do the question and answer, and also often put together with Kendra in order to then create the capability to back end. If you haven't got within the kind of FAQ set you create for the chatbot, haven't actually got the answers to what somebody's asking, you could then easily extend it into, could I find the answer to this question in a knowledge base of documents I may have? Quite a powerful capability. I talked really at the beginning about how Amazon has had a huge heritage in this area. And one of the things we're often doing is creating capabilities to let people exploit the services that we have built. So just as Amazon Web Services is built around the learnings that we had many years ago about how to do web services at huge scale, we've also taken things like that next best action recommendation capability and made it available for other people to use. So Amazon Personalize will let you ingest a data stream of things that you could provide, as well as what people are looking at on a website, what transactions they're having. So for example, you could use it to promote different courses or different products. You could use it to promote different offerings. So some of the video on demand providers will often have a screen of going, if you've watched this and you've watched that, you might want to watch the following things. That's exactly the use case for Personalize. Forecast, similarly, we've got many people with time series prediction problems. How do I forecast what will happen next? And forecast is the capabilities we built in our retail operation brought to bear in a way that's really quick and easy to use. Similarly, we've taken some of our fraud detection capabilities and brought those into a service for people to use. We've also, across the whole of Amazon, written millions of lines of code. So we've created a machine learning driven code review system called Code Guru, where you can have it look at your Git repository and analyze your code and highlight the errors, the optimizations, the problems there may be, to give you an expert code review based on millions of lines of experience. And contact centers on the right hand side, we've got a capability called Contact Lens to use a contact center in the cloud using our Connect service, but more than that, to bring the AI services to bear. So to actually use Transcribe to create a written record of what's being said, to use Comprehend to understand the themes which are being discussed, and to give a smart contact center experience. So I just wanted to look, in closing really, at a few examples of how people have done things with these. So FINRA is a regulatory body in the United States that looks after the company interactions with the stock exchange. Companies have to publish documents about their filings, their company, the reports, and they have to also, they track the millions and billions of transactions on the stock exchange and try to identify where fraud may or may not be happening. So they have teams of human investigators, but they're using Comprehend and SageMaker to process the millions of documents to identify the themes of what's being discussed and said within the company filings, the company reports, or the company publications. And they're using SageMaker to analyze the patterns across all the transactions that are taking place on the exchange. Bringing those together to actually build the capability to triage the list, to direct those human investigators to look into those companies which are most worth looking at. The Amazon recognition service, that capability of actually understanding what is in an image, has been used by a number of different people. I mean, one of the ones that amuses me is actually how it's used by some dating sites like Tinder. So Tinder actually use it, and they use it in a curious way that if you upload a profile picture to Tinder, then they will use recognition to analyze the image to see what's in the background. So not necessarily looking at your face, but they're looking at the context you put yourself in. Have you surrounded yourself by loads of books or a kitchen or a sporting environment? What is it about your context that they can learn so they can create extra attributes about you that improves the matching algorithm they've got? But in terms of facial recognition, Ayla Credit is a company in Northern Africa who are looking to provide short-term loans to the most vulnerable. And they're looking to improve the identification and verification of a person's identity. How can they do that more quickly? They're thinking about providing loans. For example, if a father wanted to get hospital treatment for their child, they haven't got the time to fill in and verify all the paperwork. So they want to create a mobile app that gives instant loans. And they've used recognition as a way to verify somebody's identity without human intervention, to actually make that quicker, make that easier. What is maybe interesting, though, is that often there is a thought that facial recognition technologies work best if you're white and you're male. Whereas Ayla Credit tested out all these capabilities and found, for their customer base, which is predominantly not white, but is definitely people of color, they've focused on using this, and they actually recognized it's one of the best capabilities they could get to address this. Image analysis is a fascinating area, and we've actually extended a number of the services with custom training capabilities. So whilst they are a standard service for everybody to use, we allow you to actually extend its capabilities. So one example is the Comprehend service, where it can do topic detection or entity detection, but you can train it on previous documents to say, well, all these set of 25 documents are of this topic. Go and learn how that's true and use that learning to apply it to this new set of data I'm telling you to look at. In a similar way, the recognition service can be taught to identify specialist things. So in the lower image here, you can actually differentiate between sweet corn and field corn as two different types. Or in the top, you can identify different parts within a mechanical machine bracket. So you can actually specify what looks like a prop shaft or what looks like a clutch pressure plate, which could be incredibly powerful for manufacturing pipelines, or in fact many different image analysis problems. I've seen that brought to bear in terms of analysis of different seeds, differentiating different seed types. So as a couple of examples to close, the forecasting capability that I talked about, Amazon Forecast, we had a company called Puget Sound, who are a gas and electricity supplier. They used it to actually look at the individual household consumption patterns of gas and electricity at every residence they were serving, about 1 million, and then built an individual level forecast for each of the households. And they found that they could then aggregate a whole lot more accurately the overall demand that they had to meet and be much more efficient in the way they were doing it. It performed incredibly well to forecast 30 days out. And being a managed service with Amazon, an Amazon Forecast, it required very, very little manual effort to do this. And finally, the whole realm of human interactions, customer interactions, the capability of using the likes of Lex to do chatbots and AI services to give a natural language conversational application. So Liberty Mutual Insurance actually use this as an internal thing. Now, how often is it that within our own jobs, within our own roles, there's something we particularly need to find out? And usually it's a case of finding the person who knows the answer to a question. But Liberty Mutual actually packaged all that data together to help their own staff get the answers to their internal questions. So it's kind of an internal help desk in an automated kind of way. And with that summary, I'm going to close and pass the baton on to Vincent to dive into a deeper exploration of SageMaker for you.
So hello everybody. Normally you should be able to see my screen. I'm just confirming it's the case. Okay, fine. So I received the confirmation. So yeah, hello everybody and welcome to this third webinar of the day, so third session. So this is about how to build, train and deploy models with Amazon SageMaker. So I'm going to continue on what Neil explained just before, and the AWS machine learning stack, and I'm going to focus on the second layer, which is about the ML services. And more specifically, I will speak about what is inside the white box here. So SageMaker Studio integrated development environment and all the SageMaker sub-services that are inside of the SageMaker service. But before going too deep into the service, I'm going to take a step back and explain you again the machine learning workflow and how it looks like today. So on the left, you have first a prepare phase. So a first machine learning project will always begin with the collection of data and the preparation of this data. So we will transform the data, reformat it in order to be able to use then in the build phase an algorithm. So in the build phase, what we are going to do is to choose an algorithm or build it ourselves. So yeah, even if we want to choose one, it still requires a lot of expertise, because in this field, you know that there are a lot of algorithms from statistical machine learning to deep learning. So it can require a certain amount of expertise. Once the machine learning has been built or chosen, you then have to train your algorithm by using the training data that have been prepared. And to do that, you typically use an infrastructure, so basically compute, so servers with CPUs or even GPUs. And yeah, as a data scientist, you have to manage this infrastructure. So it's not something that we like to do, managing infrastructure, but yeah, you have to do it. So yeah, so once you have trained first algorithm, then what you will not have the right result at the first time. So what you will have to do then is tune your model, make iterations, train a certain amount of times, and then tune the hyperparameters typically and see which one of the models is best. You also have to debug the models and so on. So in the end, you will maybe make hundreds of iterations, maybe more, maybe thousands, and in the end, you will have a lot of training runs to manage, and it can become indeed finally a project on its own. So managing all these training runs. Once you finally choose so your model, and your model is ready to be put in production, you then need to deploy it. And to deploy it, again, you need some infrastructure. So typically servers in production. And again, as a data scientist, maybe you are not interested in managing this infrastructure. Then once the model is in production, you will probably need to monitor to see if the model still with time continues to behave correctly. So if there is no data drift and if the predictions are still correct and have a good quality. And in the end, if the business application based on this model is successful, then you will need probably to scale your infrastructure. So basically, you see a lot of technical challenges and also infrastructure challenges on top of data science work. So what SageMaker does for you, in fact, for all of these challenges, we have built a service that tackle this specific need. So for each, so really from experimentation to production, you have a service that can help you. And that's what I'm going to demonstrate in the rest of the session. And basically, all these services are accessible from the web-based IDE, which is called SageMaker Studio. So let's begin with the build phase. And with the build phase, in fact, you can do it in SageMaker notebooks. The notebooks are a good way to share your work, to review your work, and to collaborate with other data scientists. So concretely, how it looks like. So data scientist will receive just a URL, and then he will be able to log into the platform. And yeah, because this is a data-centric environment, in just one click, I can arrive on my SageMaker notebook inside SageMaker Studio. So as you can see, if you recognize the logo here, so this platform is based on Jupyter Labs. So for the people who already use Jupyter notebooks, it should look familiar. So here you can see my environment, and what I have is yeah, a dummy notebook, I would say. So we're going to do a walkthrough this notebook to illustrate some of the capabilities. But what you can already see is on the top left, you have, so because this notebook is running on a virtual machine, it's running on compute in the backend. And as you can see here, you can very dynamically choose and adapt, in fact, the machine that is running in the background. So you have a bunch of choice here. So you can choose the vCPU, GPU, yes or no. So and the memory. So you have you can quickly, in just one click, change the compute that is in the background. You can also yeah, change the kernel. So this should be familiar to also Jupyter users. So just yeah, here we have kernels that are yeah, optimized for MXNet, for PyTorch, TensorFlow. So you can also on the fly change your kernel. And what is also very important and a nice feature that is asked by a lot of customers is that we can share the notebook in just one click. So you just, if I click here, create, so I can choose to have also a Git repo information included here. So in my case, I haven't created a Git repo at the moment, but it's possible, and you can choose to include the output of the cells as well. So yes or no. Here, for example, if I create it, you can see that I directly receive a link that I can copy and then share with my colleagues so that they can have a view on the same notebook. So basically what they will receive is a read-only version of the notebook, and they will be able to copy it locally in their own environment. But just in one click, you can share what you have done. So for the collaboration, it's really optimal. So let's continue with the left pane. And as you can see here, you have all the directories that are that I have created. So I have a bunch of directories with the file. So it's just like a normal directory structure. You have here, as I told you, so the possibility to connect it with a Git repository. You have then all the, I would say, classical Jupyter Labs tabs. So just here to shut down my kernels if I want, or the running images. The menu of Jupyter Labs, so all the help of Jupyter Labs. And then here, the small flask here is very interesting. It's a feature that we call a SageMaker experiment. And here I have also a bunch of directories. And for example, if I choose this one, which is an autopilot experiment, if I click on that, I can see that all jobs I have launched under a certain experiment. So in this case, you can see a bunch of tuning jobs that have been done. And if I check here, you can see also, so this is also part of SageMaker experiment. So this is really to classify, to have a nice structure for all your experiments. And then you can explore them. You can, for example, sort them via the objective here. You can see which model was best and so on. So this is experiment. You have also here this small icon is for the endpoint that are in services. So it's more when the model is in production, then you will have an endpoint. The model will run behind an endpoint. I will explain that later in the presentation. You can have a view also on the production environment from SageMaker Studio. So let's continue and use this specific notebook to illustrate some of the capabilities. So this notebook is a real simple notebook. It's about direct marketing with SageMaker XGBoost algorithm. So a side note is that so I will share at the end of the presentation a list of links, and you will receive also the slideshow. So you will receive the link. But there is, in fact, on the GitHub a repository with a lot of notebooks that you can try yourself. So it's just a matter of following and choosing the right notebook. If it's a TensorFlow notebook, MXNet, or what you use. So in this case, I've taken quite a simple one for the sake of illustration. So what we do in this notebook is first, as in all the new projects and notebooks, you will have to download a bunch of libraries. So for the people that are data scientists in the audience, I assume you know NumPy, Pandas, Matplotlib, and so on. So I just download these things. Then we download the data set. So a data set here comes from this URL. What we do is we unzip it, and then you can have a look at it here. It's in fact a CSV file, but it's not very readable. So what we do is we use the Pandas library, which is the data wrangling library in Python, to show the data in a better format. So here we have the data. So these are the first lines of the data. So there are in fact more than 41,000 lines. We have just showed here the first 10 lines. And what we can see here, so how the data looks like, in fact, each row represents so a person, and you have each column represent a feature related to this person. So his age, his job status, marital status, education, and so on. So we have 20 features like that. And in the end, we have the last column is called Y. And this column is in fact the label. So this is what we want to predict. And what is it? In fact, it's so it's a yes or no. This person has accepted a marketing offer. So that's really the goal of here, this application. So it's a binary classification objective because it's yes or no. So there are two classes. And as you can see, a lot of people here answer no. So we have in fact more no's than yeses, because in general, people don't accept marketing offers. So we can have a look here. Small analysis. We have 8 times more no's than yeses. And in fact, what we are going to do is to train this model with the label, and then the goal is that when the model is trained, that you will have that you will be able to use all the 20 features as input data, and the model will predict yes, if yes or no, the person will accept the marketing offer or no. So this is really the goal of the setup here of the model. So then in the next cells, what we do is just transforming the data. So for that, it requires a bit of experience and data exploration. So I'm not going to go into too many details here, but what we can see, for example, here is that for student class, retired and unemployed, we put all of them in the same bag, because it makes sense that these kind of people don't have, maybe have less money, and so it's less likely that they will accept a marketing offer. So that's a bit the kind of transformation we do. So again, you can have access to the notebook later to see more in detail what has been done here. But what is very important is that after the transformation of the data set, we will split this data set into training, validation, and test. And we are going to put all of that in S3. So S3 is our storage. In fact, it's our storage model. So all of that, you just need to understand that what we have done here is just preparation of the data, and we have put all the prepared data into the storage service. So next, when we have prepared the data, the next thing is to choose an algorithm. And with SageMaker, we have 3 main possibilities to choose the algorithms. It's first, as Neil explained a bit, we have 17 built-in algorithms. So for these, there is no coding required. All the things that you have to do is just choose the hyperparameters, and that's it. So it's really a built-in thing, and it's the goal to for you to be able to use the algorithm as fast as possible. So I've put some examples here. There is a more comprehensive list in the documentation, but so you can have a look at it later. The second option is that with SageMaker, we support all the most famous deep learning framework, machine learning and deep learning frameworks. So you can probably recognize TensorFlow, Keras, PyTorch, and so on. So with this, what is going to happen if you want to choose these possibilities, that you will just have to bring your own script, so your own algorithm, and we'll put this script in a container. So it's a Docker container that we as Amazon have built for you. These are open source, so you can have a look at them as well. But from your script, it's very easy to use this model. It's really bring your own script. There are just a few changes to bring to your code, and then that's it. You can run on SageMaker. The third option is bring your own algorithm and your own container, in fact. So this is for the people who have who are more comfortable with Docker containers and who want to have more control on that, so they can do everything themselves, and then they can run. Next to these 3 possibilities, you have also you can also in fact use machine learning algorithms from the marketplace. So these are algorithms that are created by third parties. So it's really worth having a look at them. And you can also use the Amazon SageMaker Autopilot service that I will demo afterwards. So basically with Autopilot, it's really an AutoML feature, and it does everything. So from the preparation of the data, feature analysis, building the algorithm, training, tuning, and so on. So it does everything for you. once we have built the algorithm or chosen the algorithm, then it's time to train. So what are we going to do? How are we going to train? So basically, we're starting from the notebook, and after the preparation, what we are going to do is from there. So from SageMaker Studio. So I have here illustrated an Amazon EC2, which is my virtual machine. So this is really my virtual machine here with 2 vCPU, 4 GB of RAM inside SageMaker Studio. What we have done already is we have uploaded the data to S3. So this is already, this has been done. I've showed you the code. And what we are going to do from SageMaker, from the notebook, we are going to invoke a function, which is the .fit function. Should sound familiar to data scientists. So fit function is a function that we can find in a lot of data science libraries. And when I do that, in just one single line of code, a training infrastructure will be created just from this single line of code. So this is where SageMaker is very, very, very powerful. So you don't have to manage the training infrastructure. So the training infrastructure will be a bunch of virtual machines. Again, you can choose the amount of machines. So here there are 2 on the slide, but you can choose more if you want. You can choose the size, so the type of the machine, so the amount of CPUs, the amount of GPUs. So just in one single line of code. What is going to happen next is that from a Docker container registry, which is here the Amazon Elastic Container Registry, which is the service of Amazon, which is doing about the same as the Docker Hub for people who know. We just download the container image. We create the container from this image. So in the container, there is also the algorithm is already built in. So in the case of this specific notebook, and then the training infrastructure will be ready to train. So what is going to happen next? Amazon S3 sends the data to the training infrastructure. Training is being done, and then when the training is done, it saves your model to S3, and that's it. So very simple. Then model lives in S3. The model artifact lives in S3 after the operation. So from a code perspective, how do you do that? Basically with these lines, I said one line, but yeah, here there are a bit more, but it's a single object. So it's an estimator object. In this object, what you have to define as parameters is the container. So in our case, in the case of this notebook, we want to use XGBoost because it's a nice algorithm for binary classification. So the container variable has been defined here. So as you can see, it's XGBoost with this version. Then what we have next is a role. So this is more for the security part. So in here, so the training infrastructure needs to have access to your data. And so this is so the security, so because the training infrastructure has to access data, you can have fine-grained access to this data by using this role. So it's more a matter of security. You have the input mode, so which is file, which means that when Amazon S3, when the data is sent from Amazon S3 to EC2, in fact, it's all the data is downloaded on the infrastructure. You have also the possibility to use pipe mode. So you will stream the data if the data set is bigger. Concretely, it will be when data sets will be very big that we will stream the data. You have the output path, so it's when the model will be saved to S3. You just need to pass a directory where will I save my data exactly. And then the 2 main lines is how many instances do I want, how many virtual machines, so how many of these EC2 instances I want, and the size, and that's it. So only with this, you have your infrastructure. So I think it's the dream for a data scientist to be able to launch an infrastructure just like that in some lines of code. To continue on that, just to a side note, you can use also what we call spot instances. So this is here, I'm not going into too many details here, but just you have to know that at AWS we have unused EC2, so unused virtual machine capacity at all time, and this capacity can be used by customers at a very deep discount. So we just by adding these lines, you can save up to 90% of training cost. So it's worth having a look at it. So once the estimator is created, so I will just explain these lines after. But once the estimator is created, you just choose your hyperparameters and you call the dot fit function as I explained you, and then the training is launched. You can see the logs here, and just as I told you, here you can see that training seconds 58 seconds, billable seconds 19, because I used spot instances, and I saved here in this specific training 67% of the on-demand EC2 pricing. So yeah, this is I think really good. Next, once the training is done, what you can do, just a side note here, what can be done also in SageMaker is because what you want to do after training is tuning, and you will probably iterate a lot of times with your model. What we have is what we call automatic model tuning, and you can pass to SageMaker some ranges for hyperparameters. So this is an example of 4 parameters for XGBoost. And SageMaker will explore the hyperparameter space in this range and try to find the best combination of hyperparameters. So that's a side note on automatic model tuning. So, okay, fine, we have trained, so which is very good. So again, if we train hundreds of times, thousands of times, we have the experiments here that can help you classify, sort your different trainings and find the best tuning, the best job based on the objective, based on things you want. But this is experiment. And another nice feature is the debugger. So it's the SageMaker debugger. So when you train, so during training, it's also interesting to debug your experiments while training. So to do that, we can go a bit back here and see in our estimator what we have also defined is these lines here. And as you can see, in fact, what is the debugger doing? It's just collection of data. So it will collect data while training. So we call this data tensors, but these are metrics of the model. So while training. So here in my case, I have 2 collection configs. So the first one is metrics. So it's about the accuracy, etc., of the model while training. And you have also the feature importance. So this is an example again. So this is basically collection of data. And the second part here is about the rules. So you can also define rules. In this case, I've created a rule about class imbalance because we have seen before the data set is quite imbalanced in the sense that we have 8 times more no's than yeses. And so this kind of imbalance could impact negatively the model and training. So with this rule, we can, when the rule is applied, it will tell you during training if at a certain point it affects negatively the training. So what is going to happen is after the training, you can in fact afterwards call a specific function, a debugger function, and in my case the rule evaluation status was no issues found. So it seems that the imbalance hasn't had a negative impact on my training. So again, these rules are, you have built-in rules, you can custom, I bring your custom rules as well. But yeah, this is really done, and this is, if I just go back here, as you can see, when I call the .fit function, the class imbalance is in progress. So in fact, the debugger job is running in parallel of the training job, and it's saving all the parameters in S3 while training. After the training, and after when the training is finished, what you can do is with the data that you have collected, you can make nice graphs like that. For example, here we compare the area under curve for training and validation, so you can have a look at that. We have also saved the feature importance. So in this case, we see, for example, that feature 1, which was about the jobs of the people, and feature 5, the housing, have more impact on the decision of the algorithm to decide if yes or no the person has chances to accept a marketing offer. So let's continue after debugging. Then after debugging, we choose a model and we deploy it. So to deploy the model, again, very easy. I have even less code here. So you call this, so xgb.deploy. You have 3 parameters: an endpoint name, an instance count, and an instance type. So basically, when you deploy a model, you have different possibilities with Amazon S3. So the code that I just showed you is for the real-time endpoint. So with the real-time endpoint, what you have is basically this infrastructure will be launched when you execute this command. So again, very powerful. With just one command, you have a whole infrastructure that is launched. So this is really inside of SageMaker. So it's managed by SageMaker. And what you have is a bunch of virtual machines as well in an auto-scaling group. So auto-scaling group means that you can begin, for example, with 3 instances, and you can have you can scale up to 10, 20 if the load increases. So you have a load balancer in front of that, so to load balance the load to the different EC2 instances. And you have your clients, so customers, that can send their inference requests, so the input data, so basically the 20 columns with the person features, so the age, the marital status, and so on, and the inference endpoint will answer with a prediction, yes or no, this person will accept a marketing offer. So this is really so real-time endpoint. Then next to that, you also have the possibility to have a batch transform. So some customers are not really interested in having a real-time endpoint. In this case, if they just upload their data to S3 and then in a batch fashion, the algorithm will predict make his prediction and store the results back in S3. So these 2 options are really fully managed deployment. So this is 1 line of code. So that's really the power of SageMaker. Then you have also 2 other possibilities, is to run the model on our container services. So you will do maybe a bit more work. You will manage the container itself, or really you can run the model anywhere you like. So you just grab the model from S3, and then you can make it run on your laptop, on a server, somewhere. So it's really where you like. Okay, sorry. So just a side note on another service which is called Model Monitor. So in the same object, so in the same function, sorry, so the deployed function, you can also add some lines here. And what is going to happen is, again, we are going to capture data, but now in production. So all the data that is sent in production, so all the requests here and response will be captured. And what you can do with this is compare, so with the time, so you will have all the requests that are sent in production to the endpoint, and you can compare these requests with your training data and see if these are still aligned, because if there is a data drift, or if statistical properties of the data change with time, or if features disappear with time in the data that is sent to the endpoint, yeah, the model can be negatively impacted. So with model monitor, you can really have the right data and compare it to the training set, so you can improve or correct your model with time. Okay, but with all of that, as you can see, you still have to write code. So maybe you don't want to write code. So let's have a look at the last feature, which is AutoML. With AutoML, what you have to do is just, so again, from experiment. So first, what you will still have to do is to prepare, to download your data, and nothing. So it's just the data here. So you don't have to prepare the data, so you don't have to transform it or nothing. You just, again, split the data set and you upload to S3. That's it. Once the data is in S3, you can go to here, small flask, you click on create experiment. And here you have create Amazon SageMaker autopilot experiment. So put a name of the experiment, you put the source S3 bucket, so where your data is, the output, which is where my model will be stored, and then you choose the machine learning problem type you want to solve. So we support at the moment binary classification, regression, and multi-class classification. So you can choose the one, because if you already know what your problem is, it's better to choose it here. And from there you can choose, for example, the objective metric, F1 accuracy, or you can just use auto. And the service will figure out which kind of problem it is based on the data analysis. Click on create experiment, and then from there it will take some time to train a lot of training jobs. And here, so I've already run that. So basically the default is 250 tuning jobs, tuning jobs. And as you can see, a lot of things have been trained, so a lot of jobs. And in the end, you can compare them by objective, and you can choose the best model here. So the best of the 250 models is this one. Then what you can do next, after just to wrap up, is you can take some of the tuning jobs and you can compare them. You have a graph function here. Here, in my case, I just compared two hyperparameters. For example, here I can see that this specific circle here corresponds to this specific tuning job, and I can decide to maybe these three. I just say something, but maybe these three would interest me, and I can decide to have a more deep dive in these three models. Just before finishing on this, what is very important with autopilot is that it's not a black box model, but it's a white box. And so you can see here, you can open the candidate generation notebook, and from there you can see what the service has done exactly. So you can go through the notebook and see what the service has done. So it's really a white box. So let's wrap up. So what we have seen here in SageMaker Studio is the notebooks. So it's where we have worked during the demo, I would say. The experiments to organize, track, and compare your ML experiments. The debugger with the rules and data collection. Model monitor for when the model is in production. So, and to detect data drift and so on, and autopilot, which is the last one. So basically, again, the first slide to finish. So I tried to show you as much I could in the time ahead. There are more. There is always more with SageMaker, so there are more features. So I invite you to have a look at the documentation, or anyway, if you have questions or if you want another session, we are open to that as always. And I've put some references here for you to have a look. So SageMaker is part of the free tier. So if you want to try that for free, it's possible. So have a look at this for the conditions. SageMaker documentation. Very, very, very important is this one. So it's the GitHub. I can just quickly open it very, very quickly. And as you can see, these are all Jupyter notebooks with different examples, so TensorFlow, MXNet, Keras, and so on. So I invite you to explore that really. It's a nice point to start. And yeah, this one is here, about the containers that are open source. So the TensorFlow container where your code will run. So everything is there. So I'd like to thank you for your attention. And yeah, so I don't know if we have some time to, because it's maybe the break now. So maybe we can answer the questions afterwards, after the break, or at the end of the day, or now. Yeah,
Yeah.
let me know.
So thank you, Vincent. We have two questions, but we will keep them for at 5, I think. And we are right on time for the break. So let's take a break now of 10 minutes. And then at 3:30, after a short coffee, let's say, then we will invite Jed to present the Open Data Program, where he will share why organizations are sharing their data and how they are using that data and how they are using that efficiently. So let's take a short break. Please stay with us. So let's just keep everything open, and then we reconnect at 3:30.
Hi, everybody. This is Jed Sundwall from AWS. I run the open data team here, and I'm going to talk about open data on AWS. So let me start out by just getting out ahead of the question, which would be, why does AWS care about open data? And even before I explain that, let me just level set by explaining what we mean when we talk about open data. Open data is data that can be shared with external stakeholders. There's a definition of open data out there, which is that open data is data that can be used by anyone for any purpose at no cost and with no requirements related to the usage of the data, except possibly attribution. So sort of for true open data, according to this definition, people should be able to use it, and at most you could ask them to give you attribution if you produce the data set. That's a pretty good definition. It's not really, we're not very dogmatic about that definition ourselves when we talk about open data. We work with a lot of customers who have many different kinds of data, some of which is appropriate to be open in that way, completely open and free. But other data sets, such as life sciences data, healthcare data, in some cases genomic data. We do work with customers who have data that they want to share that may not be appropriate to share fully publicly. And so when we talk about open data, we tend to talk about data that is as open as possible. So where you're making data available to researchers and collaborators, as many as you possibly can, and according to your requirements in terms of whether or not you're sharing personal identifiable information or information that might be sensitive for security reasons. Now, the reason AWS cares about open data is that we have many customers who care about it. So we have a lot of customers, particularly within government organizations, that they are required by law to share data publicly. So on this slide, we use the UK Met Office as an example of one of these customers that various meteorological offices around the world. It is part of their mission to gather reliable and accurate data about the environment and then share it as broadly as possible with researchers. And then on the other side, we have customers, in this case, Digital Globe, which is actually now a company called Maxar, that they rely on access to data for their jobs. So they wouldn't be able to produce their products and serve their customers if they didn't have access to government data. And so we serve both classes of users. And as I'm going to explain in this presentation, the cloud provides some really unique benefits when it comes to sharing data that simply aren't possible without the public cloud. So there's a figure that we like to use, which is this 80% figure, where this is from a book called Data Driven. And to be honest, I always feel like I have to qualify this. I don't know if any really hard research went into producing this number, if any surveys were issued. But whenever I get to talk to data scientists, and I do talk to researchers all over the world, I see a lot of nodding heads. This is back when we could give presentations in person, but I would see a lot of nodding heads whenever I would share this statistic, where so many data scientists do spend a lot of their time simply cleaning up data and preparing it for analysis. And this is extremely complex work. It can be just extremely time-consuming, and if anything, especially if you're working with very large data sets, it can take more than 80% of the work, because the time required just to acquire data in the first place can be very cumbersome. And we have a term for this kind of work at AWS. This is a term we use a lot around Amazon, which is undifferentiated heavy lifting. So undifferentiated heavy lifting is all the stuff that you wish you didn't have to do before you can do the things that you want to do. And I know this is something that Neil Nacken talked about a lot in his presentation, is that a big part of our approach to providing services to our customers is focused on finding undifferentiated heavy lifting, finding the things that we know that they don't want to do and the things that they feel like are a waste of their time, and taking that off of their plate and making it so they don't have to do those things. Now, the cloud has a lot to offer in terms of removing the burden of data acquisition and data preparation from data scientists and researchers. So the traditional approach to sharing data, as I'm sure you're all very familiar with, is that the data is made available on a server somewhere, and for you to access it, you have to download it to your local resources before you can work with it. Now, that is fine. You know, it's worked for many years. The internet has enabled that to a remarkable degree, but it doesn't scale very well, simply because as data volumes grow and people's requirements grow along with the volumes of that data, network capacity is not growing at the same rate. If you, for example, wanted to access a terabyte of data, you would need to have, first of all, a terabyte of storage where you could store that data, and then you would have to have enough bandwidth to transfer that data in a timely manner. And depending on where you are and what kind of internet connection you have, downloading a terabyte of data could take 24 to 48 hours. You know, in most cases, it's going to be 48 hours or longer for most people, and that's using all of your bandwidth nonstop for that period of time. That doesn't scale particularly with satellite data. You know, I know that a lot of people at JRC work with Earth observation data that is produced in volumes that are much larger than just 1 terabyte even per day. So the traditional approach of downloading data before you work with it just doesn't really work. What the cloud allows you to do is to make a single copy of the data available in a cloud environment, and then allow people to deploy whatever compute resources they want proximate to that data. So they simply turn on whatever compute resources right next to where the data is and analyze it there. Now, I want to clarify here, the data is still moving, and this sounds very simplistic, but it's actually very powerful. The data is moving, but it's just not moving as far, right? What you're doing is you're providing, you're running whatever code you want to run, using whatever kind of infrastructure you want to run, in the cloud right next to where the data is. So you're moving the compute closer to where the data is. And this can have a very powerful effect and a very powerfully democratizing effect on research. Because what this means is that people who have never had access to an HPC or a university that had a copy of a very large data set, they can suddenly work with a massive volume of data. And they're only limited by whatever, their imagination. And then of course, they do have to pay for the compute resources that they use, but it's much cheaper to turn on a few virtual instances for a few hours to test something out, or even just for a few minutes to test something out, than to buy a computer with a really sophisticated or powerful GPU. This allows much more experimentation at much lower risk. And this approach has become popularly known as a data lake. And I know this was discussed earlier, so I'm not going to talk too much about the data lake, but I just want to sort of corroborate. This is one of the reasons why you will hear, if you're not already hearing a lot about data lakes, you will in the future. The benefits of it are simply undeniable, and it's really the data lake model or approach has come about merely due to the physics of how data works in the cloud, and how it can enable research, and really allow people to ask questions much more efficiently. And I'll just reiterate what I said earlier. If you have a question as a researcher, and the only way to answer that question is to analyze a terabyte of data, previously that would mean that your first step towards answering that question was to acquire a terabyte of data. And that's just not easy for a lot of people. Depending on how you're funded, I don't pretend to understand what your situation is in terms of funding and access to infrastructure, but we've worked with a lot of university researchers as well as researchers within commercial organizations that they are often blocked merely by the requirements for storage for them to work with data. So they say, hey, I want to work with a terabyte of data. I have to go ask the IT department for a terabyte of storage, or I need to request additional funding for infrastructure for a terabyte of data storage. That shuts down the entire research project. They just can't. They can't even get started just because acquiring data is too cumbersome. And so taking this, or providing a shared data lake and taking this model allows people or allows researchers to ask questions much more efficiently. And so this is it in a nutshell. This is how we summarize the benefit of sharing data in the cloud and open data in the cloud, is that it allows data users to spend more time on the analysis rather than acquisition. And our assumption is that data researchers are in high demand. Their time is very valuable, and any one of them does not want to spend their time simply downloading data or acquiring data. They would rather just get to the analysis. And if you're interested in learning more about what people are doing with open data on AWS, we have our website, opendata.aws, that you can go to check that out. Now, we have a program that we run where we will actually collaborate with government agencies and even some commercial entities and research institutions around the world to make data available in the cloud. And so it's called the Public Dataset Program. And it's a program where we will actually sponsor the cost of storage for high quality data sets. And these data sets actually come from the providers themselves. They're the people who actually make the data available and maintain it. It comes straight from the source. And the reason we work with these providers is because we are aligned with them in our interest to make these data sets available and experiment with new ways of making data available in the cloud, and making it really easy for people to access data in the cloud without having to download it. And all of the data sets that we provide, you can find at the registry of open data on AWS. So it's registry.opendata.aws. And here, what you can see, I'm not sure exactly how easy it is for you to read the screen here, but this is we organize the data sets by tag. There are many different tags, and one of them is satellite imagery. And so you can find all the data sets of satellite imagery that we host. We actually host quite a few data sets from the Copernicus program. including Sentinel-2 and Sentinel-1 and Sentinel-5P, and I think more on the way. So now I'm going to show some examples of data being used in the cloud in this manner. And this is a kind of a pun here. Oftentimes when people talk about data in a cloud-based object store, they'll say that's data at rest. So you put the data into S3 on AWS, and that's data at rest. We prefer to talk about data at work. S3 is really the first step you take before you can put data to work. And so first let me walk you guys through this graph, which will explain which I'll explain so you can understand what you're looking at here. So Landsat data, Landsat is an Earth observing satellite that's run by the U.S. Geological Survey in the United States in collaboration with NASA. And it's a very popular data set. I have no qualms saying I'm American, but I actually live in Germany, and I can attest that Sentinel-2 is a better satellite in every way than Landsat. But Landsat is very similar to Sentinel-2. It's an optical satellite and produces moderate resolution data of the planet. Now, there's a person that we've worked with at a company at an AWS partner called Development Seed. This guy's name is Drew Bollinger. And he did some remarkable work where he actually analyzed how long it took him to do vegetation analysis on Landsat data. And he plotted out how long it was taking him over time so that he could demonstrate how making the data available in the cloud had a profound impact on how quickly he was able to perform research. And so what you can see on the on the left side of the graph are all these points that are a bit higher up on the y-axis. And what's in this graph are roughly 90,000 points. So what he's doing is doing vegetation analysis, and each point corresponds to one sort of process, one bit of processing on the data, on the satellite imagery. And the y-axis corresponds to the time that he spent doing that processing. And it was sort of just carrying out the task, what I'll say, because it's not just processing, it's carrying out the task. So that cluster of points that you see that's higher up on the y-axis on the left-hand side is how he would do the analysis before this data became available on AWS. And it took a lot longer. It would take between about 350 and 500 seconds to analyze, to carry out the process to analyze vegetation for each of these scenes. Then it was almost exactly 5 years ago, or I guess 6 years ago, that we started making data available on AWS, where the data had been copied into the cloud and made publicly available, and the time required to analyze the data just fell through the floor. And what's going on here is very simple. Again, like I said earlier, the flipped flow of data has a pretty massive impact on research, where a lot of the time required to do each analysis previously was spent downloading a tar archive to whatever compute resource he had. And in fact, he was using EC2. So he would download this data from actually another cloud provider, download a tar archive to EC2, unpack that tar archive, find the data that you wanted to do the analysis. When we made the data available on S3, we were very thoughtful about how we went about that. And we said, we're not going to provide tar archives. And in fact, for those of you that don't know, tar files, the .tar file, TAR stands for tape archive. Okay, so it's an old time, it's a very outdated approach to sharing data, is to bundle things up into one file as an abstraction of tape. What we decided to do was say, no, we're not going to make the data available as in zipped up archives or tape archives. Instead, we're going to make each file available discretely. And what this allowed Drew to do was to analyze each data set using precisely the data that he needed to carry out the task that he needed. And the fact that he was using EC2 and that the data was in S3, that meant that he not only he didn't have to move the data very far to do the analysis, but he also didn't have to move very much data very far. It allowed for a much more efficient transference of data for him to do what he needed to do. And that resulted in what you're seeing here is sort of the difference in the differential in time here is that he saved approximately 250 days of time by having the data available in AWS. Otherwise, it would have taken much longer. Okay, so now let's see what the impact of this is. This is an example. This is an example of a thing called the Blue Dot Observatory that uses the data that uses Sentinel-2 data that's available in AWS to monitor 7,000 bodies of water on the planet. And this is a pretty significant use case because it as the creators of the Blue Dot Observatory indicate, it's possible to set up world scale systems on a shoestring budget. The approach that these people took, and there's a group called Synergize out of Slovenia that have done this work. They also created a thing called Sentinel Hub that many of you may be familiar with. So what Sentinel Hub does, what the Blue Dot Observatory does is they use data to identify bodies of water on the planet, and then they created models to do simple, fairly simple computer vision detection on them to assess, how full are these bodies of water. They can just detect the edge and sort of where the edge of the body of water is normally located and see how that changes over time. And then using that information, they're able to assess the volume of water in the lake. Now, this is a kind of process that other researchers could do using a global scale data set, and you could look at every pixel on the planet and identify where water is and use all sorts of algorithms to find water. But what they were able to do is use other open data sources to identify where sort of the location of known large reservoirs. And so they came up with this list of 7,000 bodies of water. And then again, because they were able to look very precisely at where they wanted to look, they were able to run these models. And again, the result of this is a very inexpensive approach to Earth observation and to monitoring. And like they say, the cost to process the data, so analyzing 1 month of data for 7,000 bodies of water is €6 per month. And this is the kind of thing that we find really gratifying, is that our approach is always to simply make data reliably accessible, make sure that high quality data can be accessed reliably and efficiently, and then we get out of people's way, and then they will surprise us and astonish us when they come up with solutions like this that are extremely creative and have a really significant impact. By the same token, and I know Neil mentioned this earlier as well, as that the UK Hydrologic Office also uses Sentinel-2 data available in AWS. And they've done some really remarkable stuff by running, creating their ML models, and then packaging them into Lambda, so that once again, they can run extremely efficient analysis on precise parts of the planet, using very, very small and discrete amounts of compute resource. So they're able to look at an entire Sentinel image in about 5 minutes, and they're able to do this in parallel using Lambda to identify mangroves. And they've actually, and what's been really great about this is they've been publishing their results on this on Medium. The UK Hydrologic Office has their own account on medium.com. And then Carrie Dempsey is one of the researchers there, and she's also been blogging about it on her own Medium account. And it's just been really incredible to watch what they're doing, because this is the kind of thing that I think intuitively many people would assume that to process an area, a 100 by 100 kilometer area, and to do quite sophisticated analysis on the pixels in that area, would require a large and expensive and powerful computer. And what these researchers have shown is that if you are careful about this and precise with your analysis, you can actually run really sophisticated models in a simple Lambda function, which doesn't require much time at all. Now, there's another company called Nautic AI. They use weather model data, and I believe I would be surprised, or I guess I would say I would not be surprised if I learned that they also use satellite imagery. But I know that they're a very large consumer of weather model data that's provided by the Finnish Meteorological Institute on S3. And what I like about their story is that they have a very a very particular use case and customer base that is not the kind of customer base that we on our public sector team often think about. So they work with ship captains, for commercial shipping for the most part. And so these are the people who are navigating the seas to deliver goods around the world. And any data that they can get to ensure that their paths and are safer and more efficient and more secure, they will take advantage of that. They need as much data as they can. Now, the other thing though to point out here is that this customer base is not necessarily very savvy with weather model data. It's not reasonable to expect that a sea captain also knows how to interpret GRIB files or whatever NetCDF files that weather data is provided in. They have many other responsibilities to worry about. What they need is an easy to understand interface that they can use on an iPad or a laptop while at sea. And that's what Nautic AI provides them, is with a custom product that makes sense out of this weather data for them in a way that they can understand. And again, this is one of the kind of thing that we are always seeking to enable, which is that for Nautic AI to access the massive amounts of weather model data efficiently and to be able to build this service would be very expensive for them traditionally. And so while they're a commercial company, when they were starting out, they would have to ask their investors or somehow borrow money to buy infrastructure and build processes merely to acquire open data and to do it really quickly. And the point of sharing data openly in the cloud is that it allows them to not have to do any of that stuff. And as a result, it allows them to shift their risk into more value add areas. So they don't have to risk their business or assume risk merely to acquire data. And when I say assume risk, really another way to say it is just they don't need to spend money that is scarce for their business merely to acquire data. If they don't have to spend that money, that means that they can invest more heavily in information design, user experience design, and other efforts for their business to make sure that they can provide a quality product to these users. And I always emphasize this because when I talk to a lot of people, especially in the policy realm, about open data policies, there's an assumption that the idea of opening data is to have the government open up data so citizens can use it, can access it, and do whatever they want with it and get answers they want. I believe that is true, but I believe that the way that actually happens is through innovations in data visualization and data product design and data product development. And the key to getting better information into the hands of citizens, or in this case, ship captains, is not merely to just make data available in the cloud and say, okay, ship captain, come look at the data. It's actually to make data available in the cloud so that people can innovate on top of it. Okay, and then here's one final example that I'll provide, which again demonstrates the power of making very large data sets available at scale in a cloud environment. So EOX is a company. They're based out of Austria. They work with Earth observation data, and they were able to use open source tools that integrate directly with the data, Sentinel-2 data that's stored on AWS, to create the first global cloudless mosaic from Sentinel-2 data. So they were able to look through every pixel that we hosted, and they created a model that very efficiently detected clouds, and so that they could select the images with the fewest interference from clouds, or sort of atmospheric interference, and create a mosaic, a cloudless mosaic based on Sentinel-2 data. And yet again, it's gratifying to see this kind of activity, because it allowed a small company that typically one would not expect to have access to this kind of compute power, to be able to do something quite large, that previously would have required an HPC and a lot of local storage. Okay. So now I'm going to talk about the registry of open data on AWS. I will have time at the end of my session for questions. So if you have questions, please start adding them to the chat, and I'll be able to address those. But the final part of my session will be explaining how to find data sets in the registry of open data on AWS, and then how you can also submit your own. So like I said before, we have this website. We actually call this RODA, so that's the acronym for Registry of Open Data on AWS. And here you can find all the data sets that we sponsor that are available for people to access in S3. We provide it's a by design, it's a very, very simple and even simplistic interface. You can search the data sets on there, and then you can also browse data sets by tag. So for example, before I showed the satellite imagery tag, here I'm showing the sustainability tag. We actually have a collaboration with the Amazon sustainability team. So this is the team that oversees all sustainability efforts for Amazon.com, including the retail part of Amazon and AWS. And so we have a collaboration with them called the Amazon Sustainability Data Initiative. And we have a particular interest in supporting research related to sustainability, and particularly environmental sustainability. And in fact, the data sets that we store and make available through the registry of open data on AWS are used by internal Amazon teams. So as you might imagine, running the infrastructure for AWS requires quite a bit of energy. Amazon has built wind farms and uses a lot of solar energy. We have many of our regions are carbon neutral, so they use only renewable energy resources. And because of that, we have a very strong interest ourselves in understanding the impacts of the environment on our energy supply. And so Amazon is a customer of these open data sets that we make available through this program. By the same token, you can imagine that the logistics required to deliver Amazon packages is also impacted by weather, right? So it's a lot harder to deliver packages in ice and snow and things like that. And so we host a lot of weather data, like I mentioned, the UK Met Office, the Finnish Meteorological Institute, also NOAA, which is the weather agency basically of the United States. They also provide quite a bit of weather data available through this platform. Now, another thing, though, that we provide through the registry of open data on AWS is usage examples for all of the data sets that we make available. So every single data set has a space for people to add tutorials, as well as tools and applications that have been built on the data, and publications. So if people have authored papers based on the data, they can link to them there. And then, of course, if they've provided tutorials on how to actually interact with the data and do things with it, or built tools on top of it, we link them there as well. On this page, and you can see there's the URL for this up at the top. So it's registry.opendata.aws/usage-examples. And I believe we'll be sharing these slides, so you'll have all these links. we rank these based on how many tutorials are in there right now, and publications and things like that. And so I believe Sentinel-2 has been knocked down from the top spot by a cancer genome data set. But regardless, you can see here that Sentinel-2 has quite a few tutorials and tools that have been built on top of the data. The reason we emphasize this is simply because we know that merely making data just isn't enough. It's great to be able to make massive volumes of data available to people, especially really compelling data sets like Sentinel-2 and Landsat. But these data sets are not really easy to work with for most people. And we also recognize that a lot of people that want to work with these data sets might not be familiar with AWS. And so we really place a lot of value on identifying tutorials and code that is open source and that people can replicate as they learn how to work with these data sets. We want to see this as an on-ramp. Certainly we're interested in having people learn how to use AWS, but we also feel like we have a role in helping people understand how to take fuller advantage of these data sets and benefit from them. And then finally, this is all open source, right? So even the registry of open data on AWS is open source. We host the code for it on GitHub. So if any of you, for example, publish a paper or do work that takes advantage of the data sets we have on here, you can use GitHub to send us a pull request and say, hey, here's a paper that I just published that talks about how we use this data, or here's some open source code that we produce that takes advantage of this data. You can link to that from the registry, and basically just send us a pull request on GitHub to let us know what you've done. We will check it, of course. We don't want to. Of course, we trust you, but we check these pull requests before we bring them in. And so if people submit things and add new tutorials, we're always really happy to see those come in, and we celebrate that. And then finally, we have also written a guide to sharing data on AWS. So we've been doing we've been sharing data on AWS for over 10 years. It's a program that goes way back. We believe we've learned a few things along the way, and so we've come up with a book that shares some of the things that we've learned about best practices and patterns that we recommend for sharing data in a cloud environment, as well as use cases from our customers at Transport for London, Canada's Communication Security Establishment, the US Geological Survey, and the Allen Institute for Brain Science. And so this is just a free guide. You can get it at opendata.aws/guide-pdf.
Hello? So I'm not sure if other people still hear Jed, but in any case, while we are waiting, if you have any questions, please feel free to log, because we have a little bit of time left before we start to the next section. Okay, so it seems that now we have, you can hear me, but that we have lost Jed. So it seems to be some kind of symptom that when you are presenting, that your connection suddenly goes bad. So, but Jed, was actually on his last slide, so I think we can move to the Q&A if there are any questions, but I don't see any questions for Jed. We have a couple of other questions that I will tackle after the last presentation. Okay, so if there are really no questions, then we can move actually already to the last part before we will go to the Q&A at the end then. So Delger, please, we will wait for her to be ready. She will unmute and then she can start.
Can everyone hear me?
Yeah, now we can hear you. So I think you can
Yes.
start, Delger. Okay.
Are you able to see my slides?
Yeah, we can see your slide and we can hear you.
Sounds great. Thanks to Jed and Anthony. Good afternoon, everyone. My name is Delger, and I'm data scientist on the Machine Learning Solutions Lab. So today I actually wanted to share with you an overview of what ML Solutions Lab does and how we can help customers build and deploy custom machine learning and deep learning models on AWS. So Solutions Lab was really launched in 2017 with the purpose to connect in-house Amazon deep learning experts with customers to help them adopt machine learning and deep learning. We have invested over the years heavily in our capabilities to do deep learning and machine learning models, and customers will be able to leverage that to further their knowledge and build new use cases in the future. So also wanted to mention that our team is actually part of the service team. So as Neil was introducing some of our services, we work closely with the teams who are building these services so that customers can get the best value out of their AWS usage. So we add value in 4 different ways, really. So the first one is we ideate with the customers on ways to apply machine learning to solve challenges unique to the customer. So that's the brainstorming part. And then the second, we work backwards to build custom models as part of 8 to 12 week proof of concept stage. We have a huge amount of experience in solving challenging deep learning problems such as image classification, segmentation, action recognition, anomaly detection, and text analytics. So during the modeling stage, we work backwards to build end-to-end pipeline and architecture that works best to the unique needs of the customer. So you may be interested in seeing how state-of-the-art image or video-based approaches scale and perform on your dataset, or you may have already built a great model and you're looking to improve inference latency or efficiency. So we can help with challenges in these areas. So we also set up knowledge sharing sessions and openly share our learnings via weekly catch-ups during the POC model build stage, which will help really to kind of teach the customer how to fish and to deal with huge amount of data that they have available. Once we have our ML model or deep learning model, they can really only drive value if it works within the customer's IT environments, right? So we share best practices on building production pipelines for ETL and model training and deployment using continuous integration and delivery principles. And finally, it's really our purpose to for the customer's technical teams to become self-sufficient and own their solution going forward. and build new solutions as well. So the knowledge transfer is an essential part of what we do. So here's a sample of some of the customers that our team has worked with, and they're publicly referenceable. So we highlight some of the interesting use cases, but we'll also highlight some others later on. So here we worked with sports, NFL, where we're tracking players using object detection and tracking algorithms to predict pass effectiveness. We've worked with Cerner and AstraZeneca and they're large enterprises using machine learning across all stages of drug research and development. They partnered with the solutions lab team to build object detection and recognition models using tissue sample images. So these are some of the things that we've worked with and have built a huge amount of knowledge and experience in these areas. So the overarching principle is we work on use cases that are the most important to the customer, which we know will help the customer in making decisions and adapting to public policy. So in order to prioritize use cases, we require a mix of technical and business stakeholders, but really 3 pillars are essential. So as coming from the data science background, as a data scientist, we want to quickly build baseline models and iterate to deliver better results. And as Jed mentioned, data cleaning, pre-processing and labeling takes a huge amount of this workload, right? It can be 80% of your time spent on data cleaning. And this can be a big blocker. So our value is really maximized if we can satisfy some of the criteria here. So the first one is we want to be able to track success metrics and impact it has on the customer. So we want to evaluate how our model is performing on the data that we want to actually apply our model in production. So we need to have measurable metrics to track. The second is that we really need a clear path to production. As I mentioned, ML models, they're not, the way we approach them, they're not standalone research projects. We want them to be useful and for customers to actually, put them forward in production and use them in their day-to-day work. And then finally, the most important is actually data access and availability. This is related to some of the points Jed was mentioning earlier on open data sets, but we also have, ground truth and other capabilities to label and annotate data. But if annotations are available, it will help the data scientists to focus their energy on building the best models. In order to really go from the art of the possible to the art of the practical, we typically have 2 weeks at the start of the POC to evaluate and assess the data, whether it's sufficient to train models, so these things don't come as a surprise. So this is just a quick overview of the discovery process, really. The goal is first to have a diagnostic call to understand customers' context. We then assign data scientist teams internally, and then AWS business development and technical stakeholders meet customer stakeholders to do a half-day discovery workshop. And this is really important because we can then dive deep into the use cases and prioritize according to the 3 pillars mentioned before. And finally, we started the project. Just wanted to go a little bit deeper on the discovery workshop side. So after the discovery workshop, our business development team prepares a white paper, and this is really to surface architectures and resources and data needed to deliver quickly the use cases. So this white paper will be shared with the customer and iterated to understand how we can set ourselves up for success. All right, I mentioned some of the use cases before. Just wanted to share some of the recent use cases that we've worked with. So actually, we worked with a while back with Digital Globe. We partnered with them. They serve governments with commercial geospatial intelligence, and you know, they essentially operate Earth imaging satellites. So we built a deep learning model to identify images that are likely to be accessed, that are currently in need, so that they can optimize their data storage, what to store in Glacier versus S3, which is a quicker access and retrieval storage. So this was a way for us to identify how to optimize their processing on their end. Then the most recent one is, you know, with COVID-19, we built a knowledge graph actually, and based on that, as well as some of our service inputs, so Amazon Kendra and Amazon Comprehend Medical, we've built COVID-19 search, which helps researchers navigate a huge amount of articles and papers that are being published recently, as well as, you know, articles from the past on SARS and Ebola. And it helps researchers to quickly identify, ask questions, as well as quickly identify the most relevant articles and related articles as well. And finally, we have some use cases currently we're working with, which use different types of overhead imagery, as well as street level imagery to build deep learning models and identify and classify, segment, to address some of the specific business questions. Okay, coming to a close, just wanted to highlight a workshop that I did with my colleagues in the ML Solutions Lab a few months ago. This was a workshop, half-day workshop we did at Applied Machine Learning Days conference in Lausanne. And the main topic of the workshop was on adding interpretability to deep learning models. So we covered 3 different areas on using tabular data, time series, as well as image data. And we've covered a couple of topics such as GradCam and salience maps that really enable us to visualize and interpret the really complex models that we've built. So you see that, you know, we can do something like layer by layer visualization and trying to understand the features that neural nets are picking up in different layers as it uses to classify the images. And then on the right, you'll see that there are some salience maps and GradCam visualizations that enables us to understand. This is an image of a dog and a cat, but it identifies where the most important features lie. And this is really important for data scientists to communicate the models that they have built to enhance and convince you know, public policies on what exactly is our models actually picking up. So this is an important topic, and we have a plan to do a workshop targeted on a couple of use cases. So I'm happy to take also any questions on that. I finished my presentation, but I'm happy to take any questions here.
Yeah, so far we don't have any questions there. Thanks a lot, Delgar. I think here also on this last bullet point, so we already discussed a few use cases where we could add this interpretability part, but this has to go through a nomination process or a qualification process, let's say. So let's dive deeper in that in a separate session. But we would be very happy to add that part to one of the identified use cases. Let's wait a little bit, but I don't see any specific question now for this. While we still have a lot of people on the call, so that's very good. So if there are no more questions, but feel free to still log your questions at any time. We can take them now, or we can even take them after the webinar. So please continue on logging your questions if you still have any. In the meantime, I will take this opportunity to quickly finish my presentation, if that's fine, because actually I was disconnected earlier on this afternoon, so it would be good if I can actually also finish my presentation. So let me, so this one, oops. So I think you can see my screen, right? And after that, we will go to the Q&A. So if I was well informed, I disconnected on this slide. So just to recap, if you want to start and get an account, please connect with Digit, and they will provide you with an account. They also have this wiki page where you can access for more questions. And don't hesitate to contact us on this email address or directly on my email address if you want, for the next steps and for the process on how to onboard. And we also made this FAQ available with the most common questions we receive on whatever services we are providing, but also on security and compliance. So this slide is actually a slide I've made just to share what we see as the most, let's say, practical ways to start building your pilot if you do not have yet really a lot of expertise present in your team on AWS. So one of the ways is to engage with one of our partners. So we have tens of thousands of partners, split it in two types: consulting partners and technology partners. So technology partners are typically partners that have built their solutions on top of the AWS stack. And consulting partners are typically partners that can assist you with design, with architecture exercises, with migrations, with operations on AWS services. You can look for these partners on the partner finder link. So you will have that link later on. And there you can search for your partner per country. You can also filter on qualifications or competencies, on certifications, on programs. There's a government program, for example, for our partners. But another way is also to look for the consulting partners of AWS that do have existing frameworks with the Commission and with EU institutions. So there are approximately 20 consulting partners now with such frameworks. So to repeat, actually on Cloud 2 at the moment, the DPS2 still has to open. So there's no way to procure professional services yet under Cloud 2, but you can procure actually professional services from our partners on their existing frameworks like DigitXM or other framework that these partners have. So this is the way we are delivering a lot of projects today. So our partners are actually selling their services through their existing frameworks. So another way to quickly start is maybe through the Resident Engineers program. So that's a program that we have set in place with the Digit again. And so you can actually purchase a few man days from AWS support engineers. So they can assist you for a few days in all your technical questions, in questions you have around codes or around best practices about architecture, all these kind of things. So it's a good way to have to ramp up your knowledge and to quickly tackle a lot of technical questions that you have within your team. And then, of course, the goal is that you have that you increase your own skills and you feel more confident on using our services yourself, and that you can build actually your architectures yourself. So for that, we have our AWS trainings. You can find a few trainings already online, like the few. I think the whole learning part for Cloud Practitioner is online and free of charge. But the good news is that as from today, actually we will have trainings published on the EU Learn platform. So this is just fresh news, but all these trainings from AWS are now actually accessible on the EU Learn platform with a schedule that you can see behind that. And you can register free of charge to these trainings. These are classroom trainings, so these will be provided with a teacher, and well, on an exceptional basis, they will be free of charge at the moment. So if classes get full, which we expect because there's quite a high demand at this moment, there should be a possibility to express your interest so that we can then plan additional sessions. So we really plan to schedule sessions as demand requires. Yeah, so just to clarify, when I say classroom trainings, that means that actually they are virtual, but there will be somebody to guide you through the training. Finally, on the enablement services, so if you want to start, you can also ask for an enterprise support onboarding session, so where we guide you through all the services that go along with the enterprise support. So all the accounts under Cloud 2 are going with enterprise support from AWS, so the highest level of support. And so this means that you have access to a designated technical account manager. So he's your point of contact for all your technical questions, let's say, for all your operational questions as well. But also for information requests, he can guide you through the process on how to do that. Before doing that, I really suggest that you go to the FAQ on the wiki, because there's already a lot of information on how to, for example, open a ticket in AWS, which is always very useful. You can also ask for AWS support engineers to call you back to answer your questions over the phone. So all this information is available on the FAQ. If you don't find your way, again, feel free to send an email. We also organize immersion days on specific topics like security or container services or other. Immersion days are really hands-on labs where it's a mix of presentations and coding exercises, let's say. You can ask for an architecture review by our SAs, and our TAMs will also help you in driving down your costs. So we continuously try to optimize the cost across all our customers' platforms. A little word on ProServe. So next to our partner offering, we also have our own professional services. They do not really compete. They are not there, as we say, to stay. So our partners are there more to guide you on the long term. Our ProServe are more there for very specific needs, more ad hoc needs. So they can be advisory services to advise you on how to, for example, perform organizational changes in order to adopt DevOps practices, for example. But they are also there to guide you through large-scale migrations or through machine learning solutions lab like Delger just presented. So yeah, that was just a few slides that I wanted to share with you additionally. So I don't see any new questions so at the moment. So I will stop sharing my screen, and then we can go through the Q&A, I guess. So I have here some written down questions that we collected. So I would say that let's start with the most common question. Here we have a question asking whether it's possible to have an account for free for limited time to try out and to experiment. It was partially answered, I think, in the presentation of Vincent. So with an account you can get, and with some services, you can get some free tier. So that means that for a limited amount of time and amount of usage, you can make you will not be charged for those specific services. But next to that, actually, of course, we have the availability to help you with credits for specific pilots if you would need so. So for that, we would need an estimate and just see what are the objectives of that pilot. And after some discussion, we can help you as well with some credits if you would like to. What we see a lot as well is that a lot of customers are using AWS budget, which is actually allowing you to, let's say, allocate a fixed budget to a sandbox account, for example, let's say 50 euro or 100 euro per month. And with that account, you can do whatever you want. And it's good to give actually a lot of freedom in those sandbox accounts so that people really can try a lot. And it's only 50 to 100 euro, and after that, you are you will be stopped. So that's also a way to try out things, I would say. But our solution architects can guide you through how to set that up. Okay, then I have a question for Vincent. So if you could unmute yourself, Vincent. So the question is whether we can monitor the CPU or the GPU usage in SageMaker.
Yeah, so for indeed for this question, it is possible to monitor CPU and GPU. So this is done with the integration of SageMaker with another service which is called CloudWatch. So if you check in the documentation, there is a section monitoring, and you can see there are metrics for CPUs and GPUs.
Okay, so that's easy. I also got a remark that in your presentation, Vincent, the coding was not always visible. So just to reassure everybody, we will share all the code that Vincent has shown. We will also make sure that all the links that we have shown and shared, that they are working. So we will do a little bit of a review on all the quality of the documents that we will share afterwards. Then another question for you, Vincent, is about the code of the built-in algorithms. So people can see the code. Can you confirm that? And also, is it possible to modify that code?
Yeah, so for built-in algorithms, you can't see the code because the code has not been open sourced. So what you can see is the code of the open source containers. So it was in the second scenario of my slide. So with the support of TensorFlow frameworks, mxtend, and so on. So for this, the code of the container has been open source. But for the built-in algorithms, so for the 17 built-in algorithms, it's not open source. But what you can do, if you're interested in one of them, in fact, basically, they are all based on open source version. So, for example, XGBoost, you can find an open source version, so you can start from there, but not from the built-in algorithm itself.
Okay, thanks a lot. And then I think I have here a question which is a bit more complicated on the costs, let's say. So I will go through the question. So it's regarding the flexibility in the choice of virtual machines while training and deploying models. So it's an interesting and useful feature for data scientists who are not always able to guess the amount of resources needed. But it seems that internally, when the I5 unit at JRC, who's managing the cloud services, is communicating with Digit, you have to provide a detailed estimate on the type of machine to use for the business case, and you need to estimate the cost for up to 1 year of usage. this seems incompatible with the on-demand capabilities offered by AWS. So this is actually more, I would say, related to the way that Digit is now at the moment cross-charging internally in the cloud broker model. So the spirit of Cloud 2 and the contract has also been set up in that way. It's really to offer on-demand usage. So there's nothing preventing in the contract on-demand usage. And so there's also actually nothing preventing you as a user to continuously optimize your service and to change normally virtual machines sizes and types during your project. I know that Digit and the Cloud Broker team, they have requested these use case estimations, and they, especially for 1 year, because there have been challenges, let's say, in collecting the cash afterwards internally between the units within the commission. So because of these challenges, they are working in this way, but the cloud broker team is working on a cloud consumption dashboard and is improving the cash flow management tools they have to actually allow more flexibility. I would say that if this is a challenge, well, first of all, we are there as an AWS team to support you on the architecture work that you have to perform there. So if we can already help with the cost estimation, we are happy to do so. So feel free to reach out so that we can make an estimate. Next to that, if it's still a challenge to provide that cost estimation for 1 year upfront, we are at least on a, I would say, bi-daily basis, working with Digit to further improve the way Cloud 2 is functioning. And so if we can collect your feedbacks and your demands, and we will work with the Cloud Broker team to make sure that well, you can make usage of the on-demand capabilities of the cloud. I know that Digit has the same spirit in mind. There are just still a few, I will call them FinOps challenges, but we are both working to improve that. So feel free to provide that feedback so that we can further improve together with Digit. And so far, these are the questions I see in the tool. So I'm looking at the panel with my colleagues to see if there are additional questions. But it seems that we have actually addressed all the questions. So like I said, don't hesitate to send more questions afterwards to the Cloud2 email address. We will share you the link to the recording and to the slides and all the material shortly. I cannot put an exact date on that, but we will do it as soon as possible. And that's it. And I would like to thank you very much for making yourself available for this webinar. I would also like to thank all the speakers, of course. And I'm probably missing something here at the end, but that will be it, I think. So thanks a lot for joining.